Hi, my name is Ross, and I created a simple number generator for statistical random sampling. So the basics of what this program does is it's at its core just going to generate a random number that you can use in statistics. In statistics generally, when you have something you need to sample or survey, you want to have your results to be as random as possible because ideally you can't. For example, if you had to get a survey of 1,000 people, it would be very impractical to ask 1,000 people questions. So what you can do is ask about 100 people, about 10% of that, but the best way to find those 100 people is through a random sample, in the sense that when something is random, theoretically, it'll be at best a representation of a general population rather than just handpicking it.
Because now, how do you know what sample size to use in order for it to reflect the original 10,000 people?
Well, the best rule of thumb is generally about 10% of your population.
Okay.
So it doesn't have to be 10%, but that's the best sample size you can get that's in a still practical sense. So for example, it's just literally, if you had 100 people you need to get a question from, you can assign each person a number, and this program is here just to generate those random numbers so that you don't have to use a calculator or a random digits table. So for example, I can input my minimum number. Let's say I wanted to do 1 through 100. So I'll input my minimum, my maximum, and it's going to ask me how many numbers it wants me to generate. Say for example, I needed to only get 15 of those, or let's just do 10. If I get 10, it'll then spit out 10 random numbers that you can then use for your sample. They're not ordered, and it doesn't account for repeats, so you need to consider that whether repeats are even allowed in your sampling.
Okay, so what are the first three numbers?
55, 80, and 94.
Okay, run this again,
Okay.
and let's make sure you don't get the same list.
Okay. So we're going to do 1 through 100 again. And let's say we still want 10.
Right.
Now you have 41, 70, and 68.
Okay. So every time you run it, you get a different list of numbers.
Mm-hmm.
Okay.
So let's go and see how this code works. Again, it generates a random sample using a loop, which I'll explain a little later in the code. I have my preprocessor directives here, where you're including IOStream, which you're going to use in all your C++ programs. You have a standard library, which is here for the random function that's stored in the computer. And you use time here for a seed, which I'll explain a little later in the code. I'm going to start with this line here, void random number. It just declares the function, and it's going to let you know. I'll define it later, but this is just saying there is one function aside from main. It's going to be random number, but this is the function that generates the random number. Your main code is right in here, and it doesn't seem like much because basically this code just says that you're going to execute the random number function, which is this part right here. So when you open up void main, it's going to call for the random number function, which is this, basically. It will generate random numbers. So you have your variables here. You have your minimum, maximum, and quantity. Those are all the variables that you input into your program within a range. I input 1, 100, and 10. The quantity is how many numbers you want to generate. So I start simply with a simple cout function, cout statement, which will put out this text so you know what the program is about. I have a minimum number, a maximum number, and you have CA here, which is where you input your variables. So the variable min and max go here and here, and this is where you're inputting the variables that get stored in the computer. Now you have to do a random function. It's a function here. srand is a function stored in the standard library that basically will generate a random number based on what you start as the seed. With this here, I have time 0, which basically means that a computer has an algorithm for generating a random number, and theoretically, every computer would start with the same few random numbers. So when you have a seed, what you're basically doing is starting it off at a different point, so that if I were to do a random number on 3 different computers, it wouldn't pick the first 3 random numbers that's the same. They're going to start at different points in the function. So when I set the time 0, it basically says you're going to start with a number that is equivalent to the current time on the computer, or at 0. It's basically a seed that lets the computer know where to start to make sure it's true to the number.
You know, when the Windows clock, when you pick to see what time it is and what date it is, that is calculated using a formula, right? Well, the pseudo-random function that's used to calculate random numbers that Ross is using is based off of that seed value no two values for the time are the same, because it's only going to be 10:23 and 11 seconds on September 11th, 2004, only once, right?
Every time
And every time you run the program, it's going to base it off a different number, because it'll never be he won't be able to run the program simultaneously more than once, right? So he's guaranteed, if he uses that seed value, he's guaranteed to have different random numbers every time he runs the program.
and again, that's the use of that the algorithm, like Mr. Rowe said. And the last part deals with the quantity of how many numbers you want to generate it. I know we haven't gotten here yet, but this is basically a simple loop. And what this loop does is it tells the computer to keep executing the code as long as you have a certain value less than the value you input. So to simplify it, for example, say our quantity here is 10. You're going to input 10 for this variable. And what this loop tells me is that as long as my I value, which I'm just going to call index for the sake of this, whatever you put there doesn't matter. As long as this value is less than 10, it's going to keep executing functions for the numbers. And this part here tells you that you start with 0, and every time you execute the function, I is going to be one number greater. So the first time I pick a random number, I is 0. The second time, I is 1. The third time, I is 2. And by the time I reaches 10, I is no longer less than the number you input. So it stops the function. That's essentially what a loop is. It basically tells the computer to keep doing the same thing until a certain point, which you use using this quantity input. And the actual random function is here. It's a little complex to explain, but essentially what it does is it takes your maximum and your minimum and subtracts them. So for example, for a better example, say you wanted something from 25 to 100, your maximum minus your minimum is 100 minus 25, 75. And what it does is it takes the modulus of those numbers, which, in simpler terms, when you divide a number, you usually get a remainder if you're not using decimals. So if you have 28 divided by 3, you get 9 remainder 1. The modulus between 28 and 3 is 1. It's only the remainder value. The maximum and minimum in this case doesn't really matter, because all it does is it'll take the modulus of that difference and use it for the random number generator. Because the computer's rand function will generate a number based on an 8-bit processor from about, I think, 1 to about 37,000. And obviously, if your range is going to 100, you don't want to get like 24,000 spit out at you. So what the modulus does is it'll make sure using that algorithm to restrict it to your maximum number, and without even a maximum certainly go to a lower number as well. And then this part here is just a display of the number function. So let's take a look at it one more time. Any minimum, maximum you want to do? 1,000. Okay. 50 to 1,000? Let's not do the thing. So we'll have 50, and we'll do 1,000. And say, for example, you're doing a survey, and you need to ask 950 people questions, or you need to get a sample from this 950 people population. Population is just who you're getting the information from. But I mean, in reality, you really don't want to get 950 people tracked down. So let's simplify it to about 80, which is doable.
So, as an example, to piggybacking on what you're saying, Russ. So my neighborhood might be, 10,000 people living in my neighborhood, and there might be a company that goes in there and wants to know whether or not people in my neighborhood feel that the economy is doing pretty good, or if things are kind of looking optimistically from an economic standpoint. So we don't want to poll all 10,000 people. You don't want to knock on 10,000 doors and ask the questions of those 10,000 people, right? You want to pick 80 random people out of that group, and then hopefully that number will be representative of how most people in my neighborhood feel.
There isn't an exact way to find out how many people you should be sending implementation. Simplicity is better than using a number. In this case, as long as you have a good representation. Because in a perfect world, you would love to use all 10,000 people. But some people would work, and some people you're technically not allowed to ask people to do the routine. So you're going to have a lot of misrepresentation on that side.
Okay, so let's say, just for argument's sake, that in my neighborhood, I've been chosen to be number 37.
Okay.
Run it and see if
Right.
they're going to be knocking in my house.
For example, to make sure it's random, you can literally just organize everyone alphabetically and assign the first person to number 1, second person to number 2, keep going until you. So we're going to find 950 names of people in alphabetical order, and I'm going to sample these 80 people. You're going to go. It'd be best to organize these in number order, but for example, I'm going to knock on number 117 door. Say number 117's last name is Beal, for example. Or you're going to go up to that person's door because they're the 117th person. And you know that it's best to do something in this random way so that you're sure it's a good representation of the whole.
Can you scroll down and so we can see the other numbers? Because so far, okay. At the beginning, we were just getting Russ 3-digit numbers, but now you've got 2-digit numbers interspersed.
You have 94.
Yeah.
Right. And I mean, technically, it's just as likely to get 1, 2, and 3 as it is to get 500, 600, 100. It's just in this sample, you didn't necessarily some different numbers. Right. But that's the beauty of the randomness. You know it's completely random, even though it may seem very strange to get 5 numbers in a row. Every number has a chance to get that same representation.
This is Ron. This very good, outstanding explanation. Outstanding, very good code, very well written code. And it apparently does what you set it out to do.
Let's see. Number 1 showed up.
Wow. Look at that.
Hey, look at that. That's cool.
Wow.
So that is the random number generator. So when you take statistics in the future, use it for your calculator.
Exactly. Not only that, but if you ever need to generate some set of random numbers in your code, now you can refer to Ross's code and implement it in your code. Okay? That's what I'd like to do. I'd like to set up a repository of code that you guys do together in class, and then use each other's code to build on your program. Okay?
Thank you.
Thank you very much, guys.